To find the derivative here, we need to use the quotient rule. There is a high function and a low function. So the derivative by the quotient rule will be low d high minus high d low all over low squared. So y prime is low 1 minus sine x. D high, the derivative of cosine is negative sine, minus high cosine d low, the derivative of the bottom. The derivative of 1 is 0. The derivative of sine is cosine. So that's a negative sign. That makes this negative cosine. All over the bottom squared. 1 minus sine x all squared. Now we'll clean that up. We'll have to use distribution with this negative sign through the first two terms here. And we can multiply the cosines together. That makes negative sine x plus sine squared x plus cosine squared x. Negative times negative is positive. Cosine times cosine is cosine squared, divided by 1 minus sine x squared. Then, maybe not immediately apparent, but upon closer review, you might notice that sine squared plus cosine squared is of the Pythagorean identity. That chunk is 1. So that leaves us with negative sine x plus 1 divided by 1 minus sine x all squared. And although these things are in different places, they have the same sign. So we can cancel one of them. Negative sine x plus 1 is the same thing as 1 minus sine x, leaving me just 1 in the numerator and 1 minus sine in the denominator. So that is the final simplified derivative for this expression. Some additional examples with trig functions use product rule or quotient rule, or maybe you want to simplify before you do that. For example, cosecant times cotangent as it stands would need the product rule, f times g, product. But maybe I can rewrite it. Cosecant is 1 over the sine of x, and cotangent is cosine over sine. So this is cosine x over sine squared x. That would be something that I'd need the quotient rule. Now I'm not sure about you, but I'd rather do the product rather than the quotient. So I don't think we get any easier by doing that. It's worth an investigation. Let's say we choose the product method. So the product rule for g prime will be f prime g plus f g prime. So f prime, the derivative of cosecant, is negative cosecant cotangent, and we need a regular old g, don't differentiate g, just cotangent, plus f, the original f, non-differentiated, cosecant, times the derivative of g, negative cosecant squared. Now we can simplify. This would be negative cosecant times cotangent squared. By multiplying these two together, they make a squared, and we had a cosecant squared times a cosecant. We'll make it cosecant cubed. And it's negative, right? So we'll change this sign to just a minus. Now in the textbook, I believe they factored out a cosecant. So negative cosecant x times cotangent squared plus cosecant squared for the derivative g prime. Either one will work. I don't need you to factor it, but in case you need to factor it to make sure that you're getting your homework questions right, you should be able to do so. Now the next problem, y equals sine x plus cosine x times secant. Maybe that will simplify. For example, secant is none other than 1 over cosine x. So if I were to take 1 over cosine x and distribute through here, let's see what we get. Remember, we did not differentiate y, we're just rewriting it. That would be sine over cosine plus cosine over cosine. So sine over cosine is tangent, and cosine over cosine is 1. Well, I like that better than what we were looking at before, which would have been product rule with a big F here and a G here. So in the least I want to distribute, and then even better if I open this secant up and get to simplify the trig functions. Now I can differentiate y as simply the derivative of tangent, which is secant squared, and the derivative of 1 is 0. So that was a quick and easy derivative after we did some simplification. Now if you don't do that simplification first, that just means that you'll get a big ugly derivative and you have to simplify that derivative to get to the easy one. Like whatever you get from product rule is going to turn into that same derivative. Just a matter of when you do the simplification. So let's do one more example, an application. If we have a function that describes position here, the x value of position is 3 cosine t plus 4 sine t. This is like a simple harmonic motion of a particle. And x is in feet and t is in seconds. We can find the position when t equals 0, pi over 2, or any value that we would like. So position just happens from this position function. X equals 3 cosine of t plus 4 sine t gives us position. When t equals 0, we want to put 0 into that equation. So for t equal to 0, we get that x equals 3 times the cosine of 0 plus 4 times the sine of 0. Cosine of 0 is 1, sine of 0 is 0. So x, the position, is simply 3. And for t equal to pi over 2, x is 3 times the cosine of pi over 2 plus 4 times the sine of pi over 2. At pi over 2, cosine is 0, so that term goes away, and sine of pi over 2 is 1. So the position of this particle at t equals pi over 2 is 4. No calculus there, just evaluating a function. However, if we are looking for the velocity, then we want to talk about the rate of change of this particle. If this is its position, what is its velocity? And the velocity is the derivative of position. So if we have a position function x in terms of t from above, 3 cosine t plus 4 sine t, we can find the derivative, x prime. 3 times the derivative of cosine is negative sine, plus 4 times the derivative of sine is cosine. This function, the derivative of the position, is the velocity. Once we have the velocity function, we simply want to evaluate that at t equals 0 and pi over 2. So at t equals 0, we have that the velocity, or the first derivative of position, is negative 3 times the sine of 0 plus 4 times the cosine of 0. And that value is 4, because cosine of 0 is 1 and this term is 0. Or we can find the velocity at t equals pi over 2. Then the velocity is the first derivative of position, negative 3 times the sine of pi over 2 plus 4 times the cosine of pi over 2, and negative 3. Now we probably should assign some units to this, so scrolling back up to the problem, we see that x is in feet, so position are in feet, and t is in seconds. So our velocity is a distance, feet, per time, second. Feet per second.